Okay, moving on to the next section here in Earth Science, and that is the rock cycle. So we'll be studying some rocks and how they're created over the next few weeks in the rock cycle. So here we go.
How it came to be? The story begins about 4.5 billion years ago, as gas and dust come together to form the rocks that make up our planet. Created from elements forged far off in the galaxy, rocks really are the stuff of stars. And so are we. Rocks, and the minerals they're made of, tell us the story of our planet. Look closely. Atoms are the building blocks of all matter. Combined, atoms form molecules. Minerals are made up of billions of molecules, which are often arranged in crystal structures. Minerals can crystallize from semi-molten rock called magma. When magma cools and solidifies, it forms igneous rocks, one of the three main rock types: igneous, sedimentary, and metamorphic. Granite is an intrusive igneous rock, commonly found on the Earth's continents. It has large crystals because it cools slowly, deep below the Earth's surface. When a volcano erupts, lava cools quickly to form small crystals, creating extrusive igneous rock, like basalt. Basalt makes up much of the ocean floor and also most of the moon. Over time, rocks are broken down by weathering effects like water, wind, heat, or ice. Small fragments, known as sediments, wash into lakes, rivers, and the sea. Here, layers of sediments compact and cement together over millions of years to form sedimentary rocks, like sandstone. Limestone is another kind of sedimentary rock. It can form from the remains of marine organisms or from chemical reactions within sediments. Fossils in limestone are an amazing record of the past, revealing clues to changes of climate and the extinction of life forms throughout the Earth's history. Did you know the ground beneath your feet is constantly moving? The continents and oceanic crust are pushing, pulling, and sliding in a process known as plate tectonics. This heats and squeezes rocks, changing their form. Minerals realign or recrystallize to form metamorphic rocks. Slate, used in roof tiles, and marble are examples of metamorphic rocks originally laid down as shale and limestone. The way rocks and minerals change gives us a guide to their origin. A rock's size and shape and the colour and arrangement of its minerals help geologists distinguish between different types of rocks. Many layers of rocks create a section like this. With practice, you can read a rock section like the pages of a history book that goes back billions of years, almost to the beginning of the Earth's history.
Okay, so a little intro video there on the rock cycle. Much of the stuff you'll actually probably remember. Some of it will be a review. Some of it will be new, but most of it will be a review. So what's a rock? Well, pretty simply put, a rock is a mass of mineral or mineral-like matter that occurs naturally. Now, that's the key. It occurs naturally. The rocks we study in this class are all made by nature. As you probably know, there are several rocks out there, several rock types that are made by man. Like, for example, here on the bottom, this video, those are construction workers who are building a wall. Those are man-made rocks. Those are not the type of rocks we're going to study in this class. We are only going to study rocks that are created by nature. So again, a rock is a mass of mineral or a mineral-like matter that occurs naturally. The rock has to occur naturally. In other words, it has to come from Mother Nature or from the earth. So what is the rock cycle? Well, pretty simply put, the rock cycle is a process that's driven by two sources of heat. One coming from the Earth's interior, so in other words, like in this video down here at the bottom, the inside of the Earth. So that's magma or heat from the inside of the Earth. The other source of heat is the sun, because the sun basically drives all the processes at the surface of the Earth. So two types of heat drive the rock cycle: the Earth's interior heat, or heat that comes from the inside of the Earth, or heat that comes from the sun. This is a continuous process, meaning that it never stops. It always is going on, and it always will go on. It was going on before we were here on Earth, and it will go on well after we're gone. So it never stops. It continues all of the time because the plates on Earth are constantly moving. The magma from inside the Earth is constantly rising to the surface, and the sun's heat is constantly kind of baking and changing the surface of the Earth at the surface of the Earth, basically. So water, air, and land cause rocks to change. So once the rocks are at the surface of the Earth, the sun basically controls the weather, so it controls how water and air move above the surface of the Earth, and this causes rocks to change. But also land will cause rocks to change, such as earthquakes and just the general movement of the plates as plate tectonics. So it's a process driven by two sources of heat: heat from inside the Earth and heat from the sun. Three types of rocks. These will probably be just simply a review. There are igneous rocks, rocks made from heat; sedimentary rocks, those are rocks that are made from what are called sediments or smaller pieces of rock; and finally a metamorphic rock, which is a rock which is made from both the heat of the Earth and from the pressure of the Earth, or the Earth's plates and parts of the Earth basically squeezing together. So igneous, sedimentary, and metamorphic.
A pony is a riddle wrapped in a mystery inside an igneous. Don't you mean inside an enigma? Nope, I mean igneous. It's a kind of rock. Ask me how I know that.
Well, how do you know that? Well, an igneous rock is a rock that is formed by heat. So most of the time these are rocks that are formed below the surface of the Earth. Sometimes they will form above the surface of the Earth, like if a volcano erupts lava on the surface and that rock cools on the surface. That's what's called an extrusive or outside of the Earth igneous rock. But most of the time these rocks are formed inside the Earth where it's really hot, where there's magma underneath the surface, and these are called igneous rocks. So igneous rocks are rocks that are formed simply from the heat of the Earth. So what is it? Is it magma or lava? Well, here's the thing. They're actually the same thing. Magma is melted rock that forms below the surface. So like over here in this video on the left, it's rock that forms below the surface of the Earth. So it actually doesn't reach the surface, or hasn't reached the surface yet. Lava is the exact same thing. The only difference is lava is magma that reaches the surface. As you can see in this video on the right, this is lava that's actually reached the surface of the Earth from a volcano, is actually dumping into the ocean. So magma and lava are the same thing. There's no difference, except one's below the surface, that's magma, and one's above the surface, that's lava. So they're the exact same thing. One's above the surface, one's below the surface. Magma or lava, they're the same.
Sedimentary. This is a sedimentary rock.
That's cool. Aren't these My Little Pony videos so awesome? Well, sedimentary rock is just what that pony said. It's sedimentary rock, or made from sediments or smaller rocks. So these are rocks that basically have built up over time. As you can see, the video on the right, sediments have kind of fallen. This is at the bottom of the ocean, or maybe at the bottom of a large lake. The sediments in the water kind of settle to the bottom. They stack in layers, and the different layers will create what's called a sedimentary rock, as the rock as the sediments kind of press together, and over time they dry, or maybe the ocean area dries up or the lake dries up. Sedimentary rocks are formed. So they're just simply rocks that are made from smaller pieces of rock, also known as sediments. So how do these sediments happen? Well, it's a process called weathering. Whenever you weather a rock, it's basically just a situation where a rock is broken down into smaller pieces. Now this can happen a lot of different ways. Water can break down a rock, such as the ocean or rivers, lakes, streams breaking down a rock. Air can also break down a rock. Say if you're in a desert and it's a really dry environment, the air blowing around will cause the rocks to break down into smaller pieces. But also living things can break down rocks. So humans, for example, say if we were to walk on a trail over and over again, eventually those rocks are going to break down or become smaller pieces, maybe even smaller pieces of rock, smaller pieces of sand, maybe eventually dust. So weathering is just a process in which a rock is broken down by some other force. It may be water, maybe air, or it could be a living thing such as a human or maybe a plant or a tree that actually breaks that rock down into a smaller piece. So once a rock is down or broken down, it is created into what's called a sediment or sediments. And these are weathered pieces of earth material. As you can see in this video here, this is the bottom of a river or stream. You can see the little pieces of sediment that are kind of rolling along the bottom of the stream. Well, over time, those sediments are broken down into smaller and smaller pieces, and this is how sand is created. And they're moved, the sand or the sediment is moved by water. It can be moved by gravity, such as falling down a hill, or it can be moved by a glacier, which, if you don't know what a glacier is, it's basically a big frozen piece of ice in a mountain. Or it can even be moved by wind. As you can see down here in the right-hand corner, that is actually a dust storm or a sandstorm in Arizona. So you can see that there's a big difference in the sky here. You have blue sky on this side, and you have kind of a light brown or even a kind of a dust-looking cloud here. Well, that's exactly what it is dust. That's sediment. Okay, those are small pieces of rock. Those used to be very large pieces of rock that are now broken down and are being moved by the wind. So sediments are just basically big pieces of rock that have been broken into smaller pieces, and they are moved several ways by water, maybe by just simply falling down, by a big glacier in a mountain moves sediment, or in this case down in the video here, you can see these sediments are moved by wind. The final rock type we will study in this class is what's called a metamorphic rock, and you probably remember this maybe from your middle school days. But a metamorphic rock is a rock that's not only formed from heat like an igneous rock, but it's also formed from the pressure of the earth. So as you can see in this diagram, you've got heat from the inside of the earth pressing up, and you've got the pressure of the earth pressing down. So the weight of the earth pressing down, the pressure of the heated rock pushing up. When those two come together here in the middle, you have form what's called a metamorphic rock. So an igneous rock and a metamorphic rock are both formed from heat, but it's the metamorphic rock ability to have pressure added to that heated rock that changes it to a metamorphic rock. So metamorphic rock is formed by both heat and by pressure. Pretty soon we'll be doing a lab, and one of the things we'll be doing is streaking rocks. Well, streaking a rock is pretty simply put, it's basically when you're scratching a rock on a plate. And this is called streak. It's basically the color of a rock when you streak it or scratch it on what's called a scratch plate. It's created what's called a streak. Now, streak can actually be very confusing sometimes because sometimes, as you'll see in the video here below, sometimes the rock may look a certain color, but when you scratch it across a scratch plate, it actually comes up a different color. Sometimes the rock might be a lighter color, and when you streak it, it turns into a darker color. Or sometimes it might be a darker colored rock, and when you actually scratch it across a scratch plate, the streak is a different color. So streak and color of a rock are much different. Color of a rock is what it looks like simply to your naked eye, but a streak is when you scratch the rock on what's called a scratch plate, and that's the color that the rock makes. Basically like you're writing with the rock. Okay, cleavage in a rock. Cleavage in a rock is the ability of a rock to split or crack along what's called a straight surface. As you can see in the video below, the scientist here is basically breaking up a rock. And what you'll see is that rock has very, very sharp, straight edges. Sometimes these rocks can actually cut you. So as he's splitting the rock up, you can see the rock has a very sharp, straight edge. It's almost like it's in a straight line. So whenever he breaks this rock, it breaks in straight lines. It doesn't have curves. It doesn't have, any bend. It just simply breaks. As you can see, he's getting ready to break this one here again. And when he breaks it, you will see that it breaks into kind of a straight line, right? Well, he hasn't broken it yet, but when he breaks this rock, you'll see, as he's showing here, very straight, sharp edges. Okay, you don't see curves. You see straight lines. So that is called cleavage. It's basically when a rock breaks into straight, sharp surfaces. Now, fracture is very, very similar to cleavage. They're almost the same thing. However, it's the ability of a rock to break on a non-flat surface. So they kind of look alike and they can be very confusing sometimes, but fractures, when the scientist breaks a rock and it actually has curvy edges. Here he's going to break the rock from before, and you'll see very straight, sharp edges. Okay, that's cleavage. Now, he's going to show you another rock that he broke, and as you can see, that rock, I know it doesn't look like a rock, but it actually is, has curvy edges or fractured edges. So the one on the left has fracture, the one on the right has cleavage. Very sharp edges with the cleavage, very curvy, kind of broken edges with fracture. So fracture is a non-flat surface, meaning basically it's curvy or not in a straight line. Fractures when, cleavage is when the rock is broken in a straight, sharp edge. Crystal, this one's pretty easy. Crystal is basically a characteristic of a rock that's colorless and transparent, meaning you can see through it. Now, sometimes these rocks will have color. By colorless, the scientist means you can't see through it. Some of these crystals, as you've probably seen before, do have color and you can see through them. That's the key. Crystals can have color, but it's can you see light through them or not. That's what makes it a crystal. Now, crystals can be alone. You can have a rock that's all crystal, or you can have a rock that has crystals kind of inside of it. But basically, how you determine a crystal is can you see light through it. Now, it can have color, like you can see here, this one has kind of an orangish color, but it's still a crystal because you can see light through it, or you can see it reflect the light. Hardness. If you miss this one on the test, I feel bad for you because this is the easiest question on the next test. What is hardness? Well, pretty simply put, it's how hard a rock is. And it's measured using something called the Mohs scale. Now, the scientist below is actually scratching an iPhone screen, which, as you may or may not know, is a pretty strong screen. Well, how he's scratching it is he's using a diamond, which is one of the hardest minerals or hardest rocks on Earth. Diamonds, as you know, are very expensive because obviously they're used in jewelry, but one of the reasons they're also expensive is they are used to basically cut things or to scratch things. So he's using various devices here that have diamond in them. And since they have diamond in them, they can scratch really hard glass or really hard objects. The only way you can actually cut a diamond is to use another diamond to cut it. So hardness, like a diamond, is measured using the Mohs scale. So a diamond is one of the hardest rocks on the planet, or one of the hardest minerals on the planet, and it would register very high on the Mohs scale. But hardness is, simply put, how hard a rock is. And the last characteristic of rocks we will study is what's called luster. And luster is the way a light interacts with the surface of the rock. So when you shine a light on it, what's the rock look like? Pretty simply put, is the rock shiny or is it dull? On the left side, you can see these rocks. When we shine a light on them, they don't really show much. They're kind of boring lights, or boring rocks. They don't reflect light well. That's not luster. What luster is here on the right. As you can see here on the right, that's jewelry. Obviously, those are diamonds, and they have a lot of luster because when they reflect the light, you can see kind of the shininess to it, and that means that that rock or that gem or that mineral has a very high luster. So we have high luster here because you can see the light reflecting off of the jewelry. On the right, on the left side here, we have a very dull rock with low luster. So luster, simply put, is the way light interacts with the surface of a rock. Is it shiny or is it dull? Those are the notes for the rock cycle section. You'll want to show these so that you can get your points.